Welcome back to our channel. Today we discuss Naive Bayes Classifier tutorial. Have you ever wondered how your email provider filters spam or how news channels classify the articles? These tasks are accomplished using a machine learning algorithm called the Naive Bayes algorithm. Welcome to the KOREHUB. I am Dr. Fakit Kazmi. In this tutorial, we will cover the following. What is Naive Bayes? How does it work? Naive Bayes in machine learning. Advantages of the Naive Bayes classifier. What is Naive Bayes? The Naive Bayes classifier is based on the Bayes theorem, which provides a way to calculate the probability of a hypothesis given prior knowledge. It works on the principle of conditional probability. Named after the revered Thomas Bayes, this theorem has become a cornerstone in the field of statistics and machine learning. Basic probability concepts. Before diving into the Naive Bayes, let's review some basic probability concepts. Probability measure the likelihood that an event will occur. For example, the probability of getting heads when tossing a coin is 1 by 2. In the context of Naive Bayes, we use these probability measures to make predictions based on given data. Bayes theorem. Bayes theorem states the probability of A given B is equal to the probability of B given A multiplied by the probability of A divided by the probability of B. This formula calculates the probability of event A occurring given event B has occurred. This is crucial in updating our predictions based on new evidence. Naive Bayes in machine learning. Naive Bayes is a supervised learning algorithm used for classification tasks. It is particularly useful for text classification problems such as spam detection, sentiment analysis, and news classification. Despite the simplicity, Naive Bayes can perform surprisingly well in these contexts, making it a valuable tool in the data science toolkit. Advantages of the Naive Bayes classifier. Number 1. Simplicity. Unlike more complex algorithms, Naive Bayes is straightforward to implement. Its simplicity makes it easy to interpret and explain. Number 2. Efficiency. Naive Bayes is computationally efficient. It can handle large amount of data with minimal processing time. Number 3. Performance. Naive Bayes often outperforms more complex models, especially in text classification problems. Its robustness and reliability are well documented in various studies. Real-world applications. Naive Bayes classifications are widely used across different domains. Number 1. Email spam filtering. Classifies email as spam or not spam. Number 2. Sentiment analysis. Determines whether a piece of text expresses positive, negative, or neutral sentiments. Number 3. News classification. Categorizes news articles into different topics such as sports, politics, or technology. Medical diagnosis. Assist in diagnosis diseases by analyzing patient symptoms and medical data. Each of these applications demonstrates the versatility and power of the Naive Bayes classification in solving real-world problems efficiently. Conclusion. The Naive Bayes classification is a powerful tool for probabilistic prediction, especially in text classification tasks. Its simplicity and efficiency make it a popular choice in machine learning. Understanding how it works and its applications can greatly benefit anyone interested in data science and machine learning. Thank you for joining this video.